This lesson will be on implicit differentiation. Implicit differentiation is used to differentiate an implicit equation with respect to x. So let's do an example. X squared plus y squared equals 25. So using the power rule, the 2 is going to come down, so it's going to be 2x plus, again, do the same here with the power rule, 2y, and then since you're taking the derivative, you're going to have dy of dx since it's in respect to x. And then, of course, 25, the derivative is going to equal 0 because of the constant rule. So now you're going to try to solve for dy of dx. So you're going to subtract 2x on both sides. So you're going to get 2y dy dx equals negative 2x. And then you're going to divide by 2y on both sides to get dy of dx equals negative 2x over 2y, and when you simplify, it equals negative x over y. Now, let's take another example and apply it to finding a tangent line at on a graph. So let's use the formula x squared plus y squared equals 125 at the point 10, 5. So you're going to use implicit differentiation here. So again, it's going to be 2x plus 2y, and you can use y prime. It's the same as dy of dx, and that's going to equal 0. So again, you're going to subtract 2x and then eventually divide by 2y. So it's going to end up being negative x over y. So now this is equal to the slope of your tangent line, and you're going to plug in your point that you originally had. So it's going to be negative 10 over 5, which equals negative 2. So this is going to be your slope when you use point slope form. So in point slope form, it's y minus y1 is equal to the slope m times x minus x1. So now you're going to fill in the points you were given. So y minus 5 is equal to negative 2 times x minus 10. So now you're going to simplify. So it's going to be y equals negative 2x, and then it's going to be plus 20 because a negative times a negative is a positive. And then you're going to add this 5 from the left side to the right. So it's going to be plus 5. So your equation for the tangent line is going to be y equals negative 2x plus 25.
Okay, so we're going to do another example of implicit differentiation. So the problem is going to be find dy over dx. So the example is x plus y is equal to arctan of x cubed plus 4x. And first, I'm going to review the derivatives of inverse trig functions. So the arcsine, well, the derivative of arcsine is going to be 1 over the square root of 1 minus x squared, while the derivative of arc cosine of x, is going to be equal to negative 1 over the square root of 1 minus x squared. And the derivative of the arctangent of x is going to be 1 over 1 plus x squared. And the derivative of cosecant, of x is going to be negative 1 over the absolute value of x times the square root of x squared minus 1. And the derivative of arcsecant of x is going to be 1 over the square root of the absolute value of x times the square root of x squared minus 1. And lastly, the derivative of cotangent of x is going to be negative 1 over 1 plus the x squared. I kept messing up.
So in the problem we were given, we're going to be using the tan equation, since that's what we have. So it's going to end up being, so the derivative of x is going to equal 1. So 1 plus, and then you're going to use implicit differentiation here. So it's going to be 1 plus dy of dx, because you're taking it in respect to x, and that's going to equal, and then you're going to use this, so it's going to be 1 over 1 plus, and then all of this right here in the problem is going to be squared, so x cubed plus 4x squared, and that's going to be multiplied by the derivative of the inside, which is pretty much like it's the chain rule right there. So it's going to be multiplied by 3x squared plus 4. So then you're going to subtract the 1 on both sides, so you can get it on, so you can get dy of dx on one side, so it's going to be equal to dy dx equals 1 over 1 plus x cubed plus 4x squared times 3x squared plus 4 minus 1. And then we're going to simplify this, so dy of dx is equal to 3x squared plus 4 over 1 plus x cubed plus 4x squared. And then this negative 1 can change to 1 plus x cubed plus 4x squared all over 1 plus x cubed plus 4x squared. So you both have the same denominator, so you can subtract this from that. So your final equation is going to be dy of dx equals 3x squared plus 3 minus the quantity of x cubed plus 4x squared all over 1 plus the quantity of x cubed minus 4x squared.